You may be wondering, why have I gotten you to do something like this at the bottom, something with 3-digit addition and subtraction? Well, that's actually an important part of what we're going to be doing today. We've learned about the substitution method here. We've learned about the substitution method. Can somebody tell me, hands up, when is it good to use the substitution method for this type of equation? When is it good to use the substitution method? Joel, yeah. That's exactly right? When you have the variable as the subject, that's when you want to use the substitution method, right? And you can look on your sheet there. The first one is an example of that, right? So, when do I want to use the substitution method, right? When y is the subject, or when any of my variables is the subject. And that's exactly what I have on the top one. But when you look at the second one, what do you notice? That's actually not the case, is it? It's not the subject. It's not by itself. We've got something really messy here. But I can use a different method, and it's called the elimination method. So when I think elimination, I'm thinking something like this. Do you guys know where this is from? Yeah, right. We know when they do the red cross and they buzz them out. Elimination means I'm just trying to get rid of something. I'm trying to get something out of it. Okay? With this elimination method, what I want to do is I want to be able to get rid of something. The way I'm going to do that is I'm going to use one of these three options here. I'm going to add, subtract, or I'm going to create an entirely new equation here. Create an entirely new equation. Let me show you what addition would involve. So this is my first example here. Can somebody remind me again, what's the first thing I should always do, regardless of what I'm doing, when I've got simultaneous equations? First step, yeah. Really great practice. You just want to label the equations because it's going to help you reference them. So 1 and 2 is generally what we use. Now this is where this idea of adding and subtracting comes in, right? And it's going to seem a bit strange that I can do this. I'll show you why it works later. But essentially, all we're going to do with this elimination method is that I'm going to be doing my 3-digit addition and subtraction. What I mean by that is, if I draw a little line like that, okay, I'm going to say, I'm going to do equation 1 plus equation 2. Now, how am I going to do that? Well, instead of looking at your equations across like that, you can actually look at them up and down, right? Why would I want to do that? Let's see what that achieves. If I have 6x plus 2x, what would that give me? That would just give me 8x, cool. This is going to be interesting. What's positive y plus negative y? It's going to be 0, right? And then I've got 15 plus 1, that's just going to be 16. What have I actually done here? Where's the y gone?
You found out what it is.
It's gone. The y is gone. I've eliminated it. Hence, elimination method, right? Boom. We've buzzed it out. The y is no longer there. What kind of equation do I have here now? It's just a normal equation that I can solve as per normal, right? This is just 8x is equal to 16, or divide both sides by 8. I'll get x is equal to 2. Awesome, right? Can you see how what I've done is, instead of thinking about equations kind of going across, I've just thought about it in terms of like a 3-digit addition problem. I've just added these two terms, that's 6x plus 2x, y plus minus y, yep, and 15 plus 1, and that's all I've done here. I've eliminated that variable. That's a great question, Lucas. What do you think?
You substitute in x.
Exactly. Once you have one of them, right, we want to say, we'll say sub x equals to 2, and put it back into one of our equations. Now, usually I say pick the one that's easier. There's a minus there. Let's not deal with that. So let's say sub x equals to 2 into equation 1. All that means is I'm going to replace, sorry?
You're looking at a different.
This one here, sorry.
Okay.
Sub x equals to 2 into this first equation. Mick, if I replace x with 2 in here, what does that mean?
6 times.
Which is just 12, right? I'm going to get 12 plus y equals to 15. And I can just rearrange it.
15 minus 12.
Which is? Awesome. You see how we've done that? Right. Any questions on that one?
So you do simple math and then you do algebra and then you do simple.
That's it, right? Yeah. And this way, I don't have to worry about one of my equations being the subject. All I have to do is apply this method, right?